Now, let us talk about one more important reaction from phenols, that is Reimer-Tiemann reaction. Now, the name sounds a bit complicated, so how can we remember this reaction or this name? Remember, this is a reaction where we involve or where we introduce a aldehyde group on phenol. Okay, that's how you're going to remember this reaction. So whenever there's a need to introduce an aldehyde group on phenol, we are going to use the Reimer-Tiemann reaction. So now let's see how the reaction goes. So here, first of all, we will take a phenol. Okay. So we have a phenol. Okay. Now we will react it with, first let's say we have CHCl3, that is chloroform, and we will use NaOH. Now what will happen, as you know, phenol dissolves in base. So basically what we'll have here, we will simply have bond ONA, that is phenoxide salt of sodium. Alright, now this chloroform, what it will do, it will get itself attached on the ortho position as CHCl2. Alright, we have this sort of complex. Alright, now next what we'll do, now again we will react it with NaOH. Now this NaOH is not for this phenoxide ion but for this group which is introduced on the ortho position. Now what will happen, this group will directly get converted into an aldehyde group, that is CHO, and here we still have the ONA and of course this ring. Now for the final stage, what we'll do, for the final stage we'll have an acid, okay, to get back the phenolic group. You can also state it as masking and demasking, where we are basically masking the phenolic group and later on we are demasking it by some acid. So here is the final product. Right, we have introduced the aldehyde group on phenol. Now this is the reaction for Reimer-Tiemann. Now we need to understand the mechanism as well. So without wasting time, let's move to the mechanism. So for mechanism, we need to go through each and every important step. Okay, now let's say we have this phenol. Alright, now for the first step we used a base. So here we have NaOH. What will happen? Of course, you will get a phenoxide ion. Okay, so here we should have our O minus. No need for Na because we just need to play around this structure. Okay, now the next group introduced was this chloroform. So let us have the chloroform here. Now chloroform has this structure: Cl, hydrogen, chlorine and chlorine. Okay, now in first part we get this hydrogen released and there will be a development of negative charge on the carbon, and in the second step this chlorine also gets out in form of minus HCl. The HCl is removed and what we have now is simply this compound remains as it is. Okay, O minus, and for this structure HCl is already removed, so the remaining structure looks like this with a lone pair of electron and a negative charge. Okay, here this is where we have to focus now. Now what will happen, as we can say, the negative charge may come down, and because of this there will be a formation of double bond and this bond will jump out. So here we can have, okay, here we have a negative charge sitting outside, right? The remaining bonds remains as it is, and here you will have this. Okay, now interesting part. This part attacks here to just get itself introduced inside the ring, just like what happened here. Okay, now since while this group is trying to attach, there is already a hydrogen. Since all the carbon here which are sp2 hybridized already contains a hydrogen here, so what we get after the attack is this structure. So here we have a hydrogen and a carbon attached to two chlorines. Alright, now of course this is an unstable structure. Now it will try to attain stability by breaking some bonds. So here we are going to break this hydrogen free, the bond will shift here and this bond will shift here. Okay, now when this is going to move to this side, we will have a structure like this. And now since the hydrogen is moving, the carbon already had a charge and now the hydrogen will get attached by this carbon only. So we will now have a structure like this. This carbon having this hydrogen, this chlorine and this chlorine. Now how this happened? See, the bond is broken. Now the carbon again will possess a negative charge since carbon needs 4 bonds, but right now it will have only 3 bonds. So because of that, it will contain a negative charge. This hydrogen will again come to that negative charge and form a bond which looks like this. Okay, now after this part, what we'll do, we will again react it with NaOH. So on reacting with NaOH, what will happen? These Na will talk to this Cl and get them away, and they will be introduced or they will be replaced by OH. So the structure now looks like this. Okay, now what will happen? We will now simply try to remove this OH and this H as water molecule. Alright, and since these H is removed, the bond will shift to this oxygen and there will be a double bond which will result into this structure. What we can say is a final structure. And of course this. So this is, here we have prepared the aldehyde group, or we have attached the aldehyde group on the phenol, and this is the mechanism for the Reimer-Tiemann reaction.